In this video, I will show you how to solve a system of conic sections like this one. When I say conic sections, I'm talking about circles, ellipses, parabolas, and hyperbolas. In number 6, I know that both of these equations are parabolas. This is a parabola, and this is a parabola. I know that because only the y is squared in both equations. So when one variable is squared, it's a parabola. They're both sideways parabolas since the y is squared. So I don't know. I don't yet know, but probably one is facing to the right and one is facing to the left, and we're looking for these points of intersection. So what am I going to do? I think this would be a great time to use the elimination method. Do you see how the like terms are all lined up? That is great, because imagine that I were to multiply the bottom equation by -1. What would happen? Just picture that in your mind. I would get negative y squared minus x squared plus 16y plus 14 is equal to 0. Alright, I just changed all of the signs. Now, the top equation I have not done anything with. So I'm just going to recopy it the way it is. Y squared plus x. Wait, I shouldn't have put x squared. That's a typo. Alright, it's just minus x. Anyway, back to this. Plus 6y plus 8 is equal to 0. So, by doing that, I have created opposites that cancel, which is how you do the elimination method. So, the y squared will cancel, but also the x will cancel. So when I continue and combine these, this is going to give me 22y plus, oh man, okay, subtracting 22 from both sides, I've got 22y is equal to negative 22. Dividing both sides by 22 gives me y equals -1. As I build my solution set, let me tell you what I have so far. I've got something, comma, -1, because I've just got the y value. But I need the x value that goes with this. So what I'm going to do is I'm going to pick one of the two original equations and I'm going to substitute. I'll pick the top equation. So the top equation is y squared plus x plus 6y plus 8 equals 0. And we are going to let y equal -1 right now. If I do that, I've got -1 squared plus x plus 6 times -1 plus 8 is equal to 0. So that's +1 plus x minus 6 plus 8 equals 0. Okay, I've got x. Now 1 minus 6, that's -5, plus 8 is 3. So I've got x plus 3 is equal to 0. Subtracting 3 from both sides gives me x equals -3. Kabam! Now I have the x value that goes with this y value. So somehow these two parabolas meet, and they meet at only one point. That is strange. I can't wait to see on Desmos.com how that could happen. Check it out. we have the two parabolas. They're actually both opening to the left, and they intersect right, well, here at -3, -1. And that's the same value that we got when we did this by hand. We are just that good. Problem number 7. What kind of shapes are these? This is a hyperbola, and this is also a hyperbola. How do I know? I'm looking at the x squared and the y squared, and the signs are different. Positive, negative, negative, positive. Anytime the signs are different on the x squared and the y squared, it's a hyperbola. So both of these are hyperbolas. Alright, hyperbolas go like this, or sometimes they go like this. So we're just going to have to wait and see. There could be 4 solutions or 2 solutions or no solution. We don't know. Let's check it out. But what I do know is that I'm going to use the elimination method. For the elimination method, we like to have opposites that cancel. These already come with opposites that cancel, so it's awesome. I can just leave this the way it is, and if I just go to combine like terms, these cancel out and these cancel out. Negative x plus 3x, that's 2x. Let's see, 2y minus y, that's just y. 2 minus 4, that's -2, equals 0. Okay, what's the point, you ask? Well, I'm going to add 2 to both sides. So now I've got 2x plus y is equal to 2. Now I'm going to subtract 2x from both sides. So that's going to give me y is equal to -2x plus 2. That's great. That gives me something that I can substitute into one of the original equations. I think I'll just use the first equation. They actually both look equally complicated to me, so I might as well just pick the first equation I see. So the first equation is 5x squared minus y squared minus x plus 2y plus 2 is equal to 0. But y is equal to this expression. So I'm going to take this and I'm going to put it in for every y I see. So I'm going to put it here, but I'm also going to put it here. Okay, so I'm probably going to need more space in this. So that's going to give me 5x squared minus, now it's time for y squared. In fact, maybe I'll just set everything up. So I've got plus 2 and then y, and then plus 2 is equal to 0. Okay, so everywhere there's a y, I'm going to put -2x plus 2. So I've got this. So now I've got a long equation, but it only has x's. So this should be solvable. So when I solve this guy, I'm going to have to go -2x plus 2 times -2x plus 2. So that's going to be tedious, but I can do it. Little distributive property here gives me -4x plus 4 plus 2 is equal to 0. So when I FOIL or double distribute this, whatever you want to call it, I need to leave this in parentheses for another moment, because ultimately I will have to distribute this negative sign. But for now, I'm going to put positive 4x squared. Inner, I have -4x. Outer, I have another -4x. So that's -8x plus 4. Alright, might as well combine these like terms. So that's -5x. Might as well combine these like terms. So that's plus 6 is equal to 0. Now I will distribute the negative sign as I mentioned earlier. So I'll have 5x squared minus 4x squared plus 8x minus 4 minus 5x plus 6 is equal to 0. Okay, combining these like terms will give me x squared. Well, I've got 8x minus 5x, so that's 3x. I've got negative 4 and positive 6, so that's plus 2 is equal to 0. This looks factorable. X squared is x times x, 2 is 2 times 1. If I just leave everything positive, that'll make 3x. Setting these equal to 0, I get x equals negative 2 and x equals negative 1. So as I set up my solution set, here's what I have so far. Negative 2 comma something and negative 1 comma something. These are both x values. I need the y values that go with them. How will I get those y values? Oh, look! There's a y value machine right there. Let's use it. Let's see. How much space do I have? Let's let x equal negative 2, because that's the first x value. So that'll give me y is equal to negative 2 times negative 2 plus 2. So that's y is equal to 4 plus 2, so y is equal to 6. Okay, so when x is negative 2, y is 6. Okay, now how about x equals negative 1? Alright, let me squeeze this in here. Let x equal negative 1. Okay, so this equation becomes y is equal to negative 2 times negative 1 plus 2. So y is equal to positive 2 plus 2. Y is equal to 4. So that gives us negative 1 comma 4. So these are the two intersection points. So let's look back and see the intersection of these two hyperbolas. Let's check Desmos and see how we got these two intersection points. Alright, take a look at you guys. We have the blue hyperbola and the red hyperbola. They are really both doing the same kind of thing. The lower pair of branches don't actually ever touch each other. Both intersection points are happening up in here, and it's a little bit hard to see, so I'm going to zoom in a little bit. But one intersection point happens right here, okay, at the point negative 1 comma 4, and another intersection point happens right here. Now it's hard to see with the naked eye because it looks like they just fall one on top of another, but the software doesn't lie. And it does in fact match the two values that we got by hand. Number 8, we have a line and a circle. So this is a line, y equals mx plus b, and this is a circle. And I know that because the coefficients are both 1. The coefficient of 1 and a coefficient of 1. Okay, so this is a circle. Let's find the intersection points. This problem is all about substitution. Y equals x plus 5. That means I can take x plus 5 and substitute it in for y in the first equation. If I do that, I'm going to get x minus 5 squared plus, and instead of y, I'm going to put x plus 5. Alright, because y equals x plus 5. And then the rest of it, plus 4 squared is equal to 100. So I have x minus 5 squared plus x plus 9 squared is equal to 100. Well, this is x minus 5 times x minus 5 plus x plus 9 times x plus 9 is equal to 100. If I FOIL or double distribute, whatever you want to call it, I'm going to get x squared minus 10x plus 25. If I FOIL or double distribute this, I'm going to get x squared plus 18x plus 81 is equal to 100. Combining like terms, x squared plus x squared is 2x squared. Negative 10x plus 18x is plus 8x. 25 plus 81 is 106, and that's equal to 100. Subtracting 100 from both sides gives us 2x squared plus 8x plus 6 is equal to 0. I'm noticing that all three of these are divisible by 2. So might as well divide everything by 2. So that's going to give me x squared plus 4x plus 3 is equal to 0. Now this is factorable. X squared is x times x, 3 is 3 times 1. If I make everything positive, 3x and x makes 4x. So this is how you factor it. Setting these factors equal to 0, I'm going to get x equals negative 3, x is equal to negative 1. So these are my x values. So if I'm building a solution set, this is what I have so far. I've got negative 3 comma something, and I've got negative 1 comma something. These are both x values. But I need to find the y values that go with them. So how will I get these y values? I can use this equation right here. This equation is like a y factory. Let's see. So let's start with the negative 3. Let's let x equal negative 3 and see what happens. So then we'll have y is equal to negative 3 plus 5. So y is equal to 2. So when x is negative 3, y is 2. So that gives us the point negative 3 comma 2. Now let's let x equal negative 1. Okay, so then we have y is equal to negative 1 plus 5. So that would mean that y equals 4. So that's negative 1 comma 4. And these are our two solutions. This is the final answer. So let's check Desmos and see how the intersection turns out to be these 2 points. Alright, so here we have our line and our circle, blue and red. But let's take a little bit of a closer look so we can really see those points of intersection. So they seem to intersect right about here and here. Negative 3 comma 2 and negative 1 comma 4. So let's see how that matches up with what we got. Negative 3 comma 2 and negative 1 comma 4. So there you go. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.